All right, so you know how you're starting to learn about shapes in class? Like circles, triangles, the basics, right?
Yeah, absolutely.
Well, today we're going deeper, looking at how different shapes have, like, their own little quirks, special things about them that make them unique.
Exactly. It's like, every bike has wheels, but a mountain bike has those knobby tires and suspension, right? It's those specific features that really make it a mountain bike. Shapes are kind of similar. They've got general stuff, like they all have an area, they all have a boundary.
Right, right.
But then certain shapes have these extra special things about them, properties that belong only to them. So today we've got some really cool examples we're going to look at. We're going to look at circles, those regular polygons, the ones with all equal sides and angles. We've got stars and even just lines.
Okay.
And we're going to look at even text labels and even like the whole space those shapes live in, the app itself.
Wow, the amp itself. That's interesting.
Yeah, so our goal today is to really understand like what makes each of these shapes a little bit different.
Okay, cool.
Looking at it kind of like property.
Awesome.
Huh?
Okay, let's start with a shape that we see everywhere, the circle. Now, what's the one thing that comes to mind when you think about a circle?
Well, you're probably thinking about the radius, right?
Yeah?
And you'd be right. That's like the key shape-specific property for a circle. And it's really simple. It's just the distance from the very center of the circle to any point on the edge.
Okay, that makes sense.
And the amazing thing is that single measurement, that radius, tells you everything you need to know about the size of a perfect circle. Like from that one number, you can figure out its circumference, how far around it is, and its area, the space it takes up inside.
Right, right.
So it's kind of like this one little measurement unlocks a whole bunch of other information.
That's super cool. And you know what? Our source actually has a little interactive demo to show this.
Yeah.
Imagine like a violet circle on your screen. And every time you click the mouse, the radius gets bigger. So you can actually see, like visually, how that one property, the radius, just totally defines how big or small the circle is.
Yeah.
It might grow, it might shrink, but it's always a circle.
Always a circle.
Yeah.
And so from one property defining that smooth, perfect curve, let's move on to shapes with straight edges. Regular polygons.
Okay.
So we're talking about shapes where all the sides and all the angles are equal.
So like an equilateral triangle where all the sides are the same, and then squares, pentagons, hexagons, all those.
Exactly. All those guys. And regular polygons, according to our source, they've got two shape-specific properties.
Okay, so it's getting a little more complex.
They get a little fancier. So one of them is radius, just like the circle.
Okay.
But the other one is called points. And points is a fancy way of saying how many sides or vertices, the corners the polygon has.
Right, okay.
And the radius, it works in a similar way to the circle. It defines kind of the overall size. Okay.
Like how big is this triangle? How big is this square? Right.
Right.
But points is what determines, is it a triangle? Is it a square? Is it a pentagon? Right.
Oh, yeah.
3 points, 3 sides, triangle.
Yeah.
4 points, 4 sides, square.
It's all coming together.
It's all connecting.
Yeah.
And there's actually a really neat interactive example for this too. So they've got this blue regular polygon on the screen. And when you click, not only does the radius increase, making the shape bigger,
Okay.
but the number of points also increases. So you can see it like morph from a triangle to a square to a pentagon, a hexagon, just by clicking, and changing that points property. It's super cool.
That's really cool to be able to see it like visually change like that. So we've got radius and we've got points. What about another shape? What about a star?
Stars. All right. So stars, they take this idea of multiple properties working together even further because they have 3 specific properties that our materials talk about. 3. Okay. Well, I'm guessing we probably got radius and points again, right? Because a star still has like that central point, and that's got a certain number of those pointy, the vertices, right?
You are spot on. You are exactly right. Radius still controlling the size. Points telling us how many of those arms or points or vertices the star has.
Okay, got it.
But the third property, this is where it gets really interesting, is called roundness.
Roundness.
Roundness. Now, I know that sounds kind of weird for a star, right? Because we think of stars as being all sharp and pointy.
Right.
But roundness is what controls how pointy how rounded those points actually are.
Okay.
So a higher roundness value is going to make the star look less like, sharp and pointy and more kind of soft and curvy.
Oh, okay. So it's like you're kind of like adjusting the sharpness of the star's points.
Exactly. You got it.
Okay, I get it. And the interactive example shows a green star. And when you click, all 3 of the properties change. So the radius gets bigger, you get more points, and the roundness also changes.
Yeah, and actually, there's a great question that our source brings up. What happens when the roundness is 0?
Hmm. Well, if a higher roundness makes it more circular at the points,
Mm.
then 0 roundness would make it, like, super sharp.
Yeah.
Like, almost like it's just a bunch of straight lines meeting at a point.
You nailed it. That is exactly the right answer. When roundness is 0, the star is super spiky. It looks like it's just made of lines.
Right.
And it kind of loses that softer, like, filled-in look. It's a really cool kind of aha moment, I think, in the source, showing how just this one property can really dramatically change how the star looks.
That's really cool. You know, the source also mentions that if you push the roundness way too high, like past 100 in their code, things start to get, like, glitchy and weird.
Oh, yeah.
Which just goes to show that even these digital properties, they can have their limits.
Absolutely. It shows that they're not just like abstract ideas. They have real effects in that digital environment, right?
Right. Okay, so let's shift gears a little bit and talk about something that looks a lot simpler, just a plain old line. But I'm guessing even lines have more going on than you might think.
Oh, way more than you think. You're absolutely right.
Okay, so what kind of properties does a line have? Like, how long is it? Which direction is it pointing in? What else?
Yeah, you're on the right track. Our source talks about properties called I1, Y1 by 2, Y2.
Okay, those sound familiar.
Yeah, so those are like coordinates, right? Like on a graph.
Yeah.
So I1, Y1, that's the coordinates of the starting point of the line. And then I2, Y2, that's the coordinates of the ending point.
Okay, so it's basically telling you where the line starts and where it ends.
Exactly. And those 4 numbers, that's all you need to define the line's position, how long it is, which way it's pointing, everything.
Wow, that's pretty efficient, just 4 numbers.
Yeah, it's super efficient.
Okay, so if you change those numbers, you change where the line starts and ends. That makes sense. What else is there?
Okay, so lines don't always have to be solid, right? They can be dashed.
Oh, yeah.
Okay. So there's a property called dashes, which is usually just a yes or no. Like, is it dashed or is it a solid line?
Okay, so it's either on or off.
Yeah,
Okay.
pretty much. And then last but not least, we've got line width, which, as you might guess, just tells you how thick the line is.
Makes sense. You know what? The example here shows this really well because there's a blue line, and when you click, it changes the starting point, and it also makes it dashed.
Oh, cool.
And then there's a red line, and when you click on that, it changes the ending point, and it makes it thicker. So you can really see all those different properties in action. The coordinates, the dash style, the thickness, they all work together to make the line look the way it does.
Absolutely. It just shows you, even though it's like the simplest shape ever, there's still a lot of different things that go into making it look a certain way.
Right.
Now, let's move on to something that's not even really a geometric shape at all, a label, which is just text on the screen.
Oh, right, like the titles or the instructions and all those demos we've been talking about. Okay, so what kind of special properties does a piece of text have? I mean, it's just words, right?
It seems simple, but it's got quite a few properties. So first off, you've got value, and that's just the actual text itself, the words that are displayed.
Okay,
Then you've got font, which determines like the style of the text.
like Times New Roman or Comic Sans or something like that.
Exactly. Like, is it a Serif font? Is it sans serif? All those different typographic styles.
Okay,
Then there's size, which obviously controls how big or small the text is.
makes sense.
And then you've got style properties like bold and italic,
Right.
which are usually just like a yes or no. Is it bold? Is it italic?
Okay, yeah, that makes sense. So it's basically like, are those features turned on or off?
Exactly. And the example shows this really nicely. You've got this label, and when you click, the text changes, the font changes, the size changes, it becomes bold, and then the italics also like toggle on and off. It's really cool.
Oh, that is cool to be able to see all of that happening at once.
Yeah, it's a nice little illustration of how all those properties work together.
You know what? There's actually a quiz question here. In the previous example, when is the label italic? And the answer is only when the value is 0.
Oh, interesting.
So it's like, it's not always italic. It only turns italic when the value is a specific thing.
Right.
Which is, I think, a cool detail because it shows that these properties, they can have like initial settings,
Yeah.
like a default value, and then they can be changed based on interactions or other conditions in the app.
Right. So it shows that they're not like static. They can be dynamic and they can change depending on what's going on.
Exactly. Okay, so we've looked at circles, polygons, stars, lines, labels. What's the last thing on our list of things with special properties.
Okay, for this last one, we're gonna like zoom out a little bit and think about the whole app itself.
The app. Okay.
Like the whole digital canvas where all these shapes and labels are living. Even the app itself has its own specific property, and that's background color.
That makes sense.
Okay.
I mean, you always see like different colored backgrounds in apps and websites. So instead of like having to draw a giant rectangle to fill the background, they just have a specific property for it.
Exactly. It's way more efficient than creating a whole separate shape, you know.
Right.
You just tell the ad, hey, this is the color I want for the background.
And the examples show setting it to like light green.
Yeah, light green, exactly.
And then there's another one where when you click, it changes the background to cyan and updates some text. So it's like a property of the whole environment, not just one individual thing.
Right, it affects the entire space. And there's actually a question in the source about this. It asks, which of the following are legal background values?
Okay.
And the answer is all of these. Because you can use color names like cyan or magenta or light green.
Okay.
You can use gradients where colors blend smoothly into each other. And you can even use RGB color values, which is like a numerical way of representing colors.
So there's a lot of flexibility there.
Tons of flexibility. And it just shows that these properties can accept all kinds of different data to define their characteristics.
Okay, so we've taken a deep dive into a lot of different shapes, a lot of different properties.
Yeah.
What's like the main takeaway message here?
I think the big idea is that, you know, shapes and even things like text and the whole app environment, they have these unique sets of properties that go beyond just the general idea of a shape.
Okay.
These specific properties are like the controls or the settings for each element, defining exactly how they look, how they behave.
It's kind of like realizing that everything you see on a screen, it's not just like there, it's built from all these like little adjustable features.
Exactly.
Yeah.
Exactly. And now that you know how shapes in the digital world have all these special controls, it makes you think, what about the objects we interact with every day in the real world? Do they have special controls too?
That's an interesting thought.
Yeah, like take a skateboard, for example. It's got properties like the length of the deck, the diameter of the wheels, the height of the trucks.
Right.
And those are like the specific properties of a skateboard that make it different from, you know, a bicycle or a scooter.
That is a really cool way to look at it.
Right. It kind of changes your perspective on things.
Yeah.
So next time you're, you know, drawing something on the computer or even just looking around you, think about all the little specific properties that make up what you're seeing. You could even experiment, like play around with some drawing apps and see how changing those properties changes the outcome.
Yeah, or think about how those properties are used in video games to create those crazy detailed graphics or an animation or any kind of visual design.
Exactly. It's all about understanding the building blocks, the unique controls that make each thing what it is.
Really cool. Well, thanks for joining us for this deep dive. Until next time, keep exploring the properties of everything around you.
Absolutely. See you next time.